The Juno spacecraft has been revolutionizing our understanding of Jupiter since its arrival in 2016. Its deep scans beneath the clouds have revealed mysteries that challenge everything we thought we knew about the gas giant. Beneath Jupiter's swirling atmosphere lies not just storms, but an enigmatic heart pulsing with powerful forces unlike anything seen before. From terrifying cyclones spinning backwards to a fuzzy core that defies physics, Juno's discoveries are rewriting textbooks. Today we're diving into the most shocking revelations about the largest planet in our solar system. The mysterious central storm discovery. Juno's ultraviolet and microwave instruments uncovered something absolutely terrifying at Jupiter's core, a massive cyclonic storm that shouldn't exist according to our understanding of planetary physics. Unlike the surface storms we can observe from Earth, this central storm spins in the opposite direction to Jupiter's rotation and measures approximately 10,000 kilometers wide, making it larger than Earth itself. In 2017, scientists led by Dr. Scott Bolton from the Southwest Research Institute first reported this bizarre storm that completely defied existing models of Jovian weather patterns and atmospheric dynamics. The storm's presence suggests Jupiter's interior is far more violent and chaotic than anyone previously believed, with turbulent motions that create powerful electromagnetic effects and possibly influence the planet's extraordinary auroras. This discovery opened terrifying new questions about how gas giants maintain their internal heat sources and complex weather systems, forcing scientists to completely rethink everything they thought they knew about planetary atmospheres. The central storm's backwards rotation indicates incredibly complex internal dynamics that researchers are still desperately trying to understand, representing one of the most significant and disturbing findings from Juno's exploration of Jupiter's mysterious depths. The beginning of the mission. Launched on August 5, 2011, the Juno spacecraft embarked on a nearly 5-year journey through the hostile depths of space to reach Jupiter, finally arriving on July 4, 2016. The spacecraft's primary mission was to understand Jupiter's formation, atmospheric composition, massive magnetosphere, and complex gravity field through unprecedented close-range observations. Equipped with sophisticated instruments including the microwave radiometer and Jovian infrared auroral mapper, Juno follows a highly elliptical orbit around Jupiter every 53 days, diving dangerously close through the planet's radiation-filled cloud tops. Mission Commander Scott Bolton and NASA engineering teams spent years developing meticulous protection systems to shield Juno from Jupiter's deadly radiation belts, designing a specialized titanium radiation vault to protect the spacecraft's sensitive electronics from being fried by the intense electromagnetic environment. This groundbreaking mission continues to push the absolute limits of planetary science and space exploration technology, offering humanity's best and closest look yet at the gas giant's mysterious core and incredibly complex magnetic environment. The spacecraft's highly elliptical orbit allows it to approach within just 4,200 kilometers of Jupiter's cloud tops during each perijove pass, collecting detailed measurements and data that were previously completely impossible to obtain. Jupiter is the world of chaos. Jupiter represents the ultimate manifestation of atmospheric chaos in our solar system, with weather patterns so violent and unpredictable, they make Earth's most severe storms look like gentle breezes. The planet's massive atmosphere consists primarily of hydrogen and helium gases, generating vertical wind speeds that regularly exceed 540 kilometers per hour, fast enough to tear apart any spacecraft attempting to enter its atmosphere. Jupiter's cloud layers reveal constantly shifting bands of storms, massive vortexes, and lightning strikes that are thousands of times more powerful than anything experienced on Earth. These storm systems create extraordinary geometric patterns and vivid colors visible even through telescopes millions of kilometers away, painting Jupiter's surface in bands of orange, brown, and white. Juno's advanced observations confirmed the presence of massive lightning storms detected by its Jovian energetic particle detector instrument, which identifies highly energetic particles directly linked to these violent and unpredictable weather systems. This incredible atmospheric complexity makes Jupiter not merely a gas giant, but a living laboratory for studying extreme atmospheric dynamics and fundamental physics of fluid turbulence, operating at scales completely impossible to replicate on Earth. The planet's differential rotation means different latitudes rotate at dramatically different speeds, creating powerful shear forces that generate Jupiter's distinctive banded appearance. Io, the volcanic moon. Among Jupiter's 79 confirmed moons, Io stands out as the most volcanically active and geologically violent body anywhere in our solar system, making it a hellish world of constant eruptions and molten chaos. Its scarred surface is covered with hundreds of active volcanoes that continuously spew sulfur compounds and molten lava fountains reaching incredible heights of up to 500 kilometers above the surface. This relentless volcanic fury results from intense tidal heating caused by Jupiter's massive gravitational pull, combined with complex orbital resonances with neighboring moons Europa and Ganymede, creating internal friction that keeps Io's interior molten. Juno's detailed flybys and precise measurements combined with archival data from previous missions like Galileo help scientists understand Io's extreme geological processes and its crucial role in feeding charged particles into Jupiter's deadly magnetosphere. Io's plasma torus, a massive ring of highly ionized gases orbiting around Jupiter, directly influences the planet's radiation environment and provides essential insights into the complex interactions between Jupiter and its satellite system. The moon's sulfur-rich volcanic activity creates a unique and hostile environment, where surface temperatures vary dramatically from extremely cold regions in permanent shadow to areas heated to over 1,800 degrees Celsius by continuous volcanic activity, making Io one of the most geologically dynamic and dangerous worlds. Research on Jupiter's magnetic field. Juno's sophisticated magnetometer instruments have been absolutely crucial in mapping Jupiter's unprecedented magnetic field, which represents the strongest planetary magnetic field in our entire solar system, measuring approximately 14 times more powerful than Earth's protective magnetic shield. This immense magnetic field extends millions of kilometers into space, creating Jupiter's vast magnetosphere that completely dwarfs even the Sun's magnetic influence in the immediate vicinity of the giant planet. Leading scientists, including Dr. Heidi Becker from NASA's Jet Propulsion Laboratory, discovered completely unexpected asymmetries and highly localized regions of intense magnetism during Juno's dangerously close orbital passes through Jupiter's radiation belts. These groundbreaking findings strongly suggest incredibly complex dynamo action occurring deep beneath Jupiter's cloud layers, generated by powerful currents of flowing metallic hydrogen existing under extreme pressure in the planet's mysterious interior regions. Understanding this magnetic environment represents far more than just studying Jupiter. It provides essential insights into planetary magnetic field generation and the protective roles these fields play around worlds throughout the universe. The magnetic field's highly irregular and unpredictable structure clearly indicates that Jupiter's internal dynamics operate through mechanisms far more complex and violent than scientists previously imagined, with profound implications for understanding how massive planets generate and maintain their protective magnetic environments. Juno mission peaks under Jupiter's surface. Juno's precision gravity science investigation revealed one of the most shocking discoveries in planetary science. Jupiter's core is not the compact, solid metallic ball that scientists expected, but instead appears to be a fuzzy, diluted structure extending up to 50% of the planet's total radius. This absolutely astonishing discovery completely challenged and overturned previous models of gas giant planet formation that had been accepted by the scientific community for decades. Detailed gravitational data from the spacecraft indicates that heavy metallic elements are far more spread out throughout Jupiter's interior than anyone predicted, mixing extensively with lighter hydrogen and helium gases in a diffuse, semi-solid core structure. The international research team, led by Dr. Luciano Ies from Sapienza University of Rome, used incredibly precise spacecraft tracking techniques to measure subtle variations in Jupiter's complex gravity field, revealing these hidden internal structures that were completely invisible from external observations. These revolutionary results strongly suggest that Jupiter experienced an extremely violent and chaotic formation history involving massive planetary collisions or prolonged turbulent accretion periods during the early solar system's development. Unveiling this incredible complexity hidden beneath Jupiter's deceptively calm-looking cloud layers provides invaluable scientific clues about gas giant origins, evolution, and the fundamental processes that shape planetary formation throughout the universe, suggesting that giant planets form through far more chaotic and violent processes than previously understood. Jupiter's formation and composition. Jupiter formed approximately 4.5 billion years ago during the earliest phases of our solar system's chaotic development, primarily accumulating vast quantities of hydrogen and helium gases captured directly from the swirling protoplanetary disk surrounding the young sun. Its absolutely massive size, containing over 320 times Earth's total mass, provided sufficient gravitational power to retain these extremely light gases that smaller rocky planets like Earth and Mars could never hope to capture or hold. Juno's advanced spectral observation instruments confirm the presence of trace amounts of water vapor, ammonia, and methane compounds, distributed at varying depths throughout Jupiter's complex atmospheric layers, creating a chemical fingerprint of the planet's formation history. The presence and distribution of these molecular compounds helps scientists reconstruct the primordial materials that Jupiter accumulated during its formation, and provides crucial data about the radial mixing and chemical evolution of compounds over billions of years. Leading research by planetary atmospheric scientist Dr. Lee Fletcher from the University of Leicester enhances sophisticated computer models of Jupiter's atmospheric composition, revealing complex chemical gradients that indicate dynamic upwelling processes and vertical mixing of gases from deep interior regions. Understanding Jupiter's formation process and chemical evolution significantly improves scientific theories about planetary system development and helps predict the potential characteristics and formation mechanisms of gas giant exoplanets orbiting distant stars throughout our galaxy. Jupiter as Earth's protector. Jupiter functions as a massive celestial guardian for Earth and the inner solar system, using its immense gravitational influence to deflect or capture dangerous incoming comets and asteroids that could potentially cause catastrophic impacts on our planet. The planet's enormous magnetosphere and powerful gravitational field significantly reduce the impact rate of potentially hazardous objects in the inner solar system, possibly providing crucial protection that has allowed complex life to evolve and thrive on Earth over billions of years. However, Jupiter's protective role represents a complex double-edged sword. While its gravity shields us from many threats, it can also gravitationally perturb objects and send them on altered trajectories that intersect with Earth's orbital path around the Sun. Comprehensive studies by leading astronomers including Dr. Alan Stern from the Southwest Research Institute emphasize this complicated dual role, examining how Jupiter simultaneously facilitates both planetary protection and potentially dangerous dynamical chaos within our solar system's architecture. Understanding this delicate gravitational balance proves essential for accurately assessing the long-term evolution of Earth's environment and evaluating the likelihood of maintaining stable, life-supporting conditions necessary for biological evolution on planets and other star systems. Jupiter's gravitational influence has fundamentally shaped the orbital architecture of our entire solar system over billions of years, creating complex resonance patterns that affect asteroid and comet trajectories, ultimately influencing the delivery of water and organic materials to inner planets during their formation. The Great Red Spot Mystery. The Great Red Spot represents one of the most iconic and mysterious features in our solar system, a colossal storm system larger than Earth that has been continuously raging for several centuries, yet recently has been mysteriously shrinking at an alarming rate. First definitively observed and documented by astronomers in the 17th century, this massive anticyclonic storm currently spans approximately 16,000 kilometers across and rotates counterclockwise at terrifying speeds exceeding 432 kilometers per hour, creating winds powerful enough to destroy any human-made structure. Juno's sophisticated scientific instruments detected incredibly complex multi-layered cloud structures and intense lightning activity deep within the storm system, providing revolutionary new insights into the energy sources and physical mechanisms that have maintained this enormous weather phenomenon for hundreds of years. Leading researchers, including Dr. Heidi Becker from NASA's Jet Propulsion Laboratory, actively study the complex atmospheric dynamics driving the Great Red Spots concerning shrinkage and investigate potential changes in Jupiter's atmospheric composition or internal energy flow patterns. The storm exemplifies the most powerful and persistent meteorological phenomena known to science, challenging our fundamental understanding of fluid mechanics and atmospheric physics operating on truly planetary scales. Recent detailed observations suggest the Great Red Spot may be gradually losing both its distinctive reddish coloration and its well-defined structural boundaries, raising serious scientific questions about whether this iconic feature will eventually disappear entirely, fundamentally altering Jupiter's appearance forever. Jupiter's rings and lesser moons. Jupiter possesses a surprisingly complex but faint ring system that was first discovered in 1979 by the Voyager 1 spacecraft during its historic flyby, revealing a delicate structure composed primarily of microscopic, dust-sized particles continuously supplied by meteoroid impacts on the planet's small inner moons. These rings, while dramatically less spectacular than Saturn's magnificent and well-known ring system, remain incredibly thin and faint, but play a surprisingly important role in Jupiter's complex magnetospheric environment and particle dynamics. Juno's detailed observations, combined with data from earlier exploratory missions, have identified 4 distinct main ring components and dozens of small, irregularly shaped moons existing within Jupiter's intense radiation-filled magnetosphere. Among these lesser-known moons, Amalthea and Thebes serve as primary dust contributors to the ring system through continuous bombardment by high-velocity micrometeorites that blast material from their surfaces into space. Understanding these smaller celestial bodies and their dynamic ring interactions offers valuable scientific clues about Jupiter's long-term evolution and the fundamental physical processes that shape planetary ring systems throughout our solar system and beyond. The ring particles undergo continuous replenishment cycles through ongoing impacts on the small moons, creating a dynamic equilibrium system where material is constantly being added through collisions while simultaneously being lost through various gravitational and electromagnetic processes, providing crucial insights into the complex gravitational interactions governing ring systems around giant planets. That's the incredible story of Juno's journey deep beneath Jupiter's clouds, uncovering mysteries that force us to completely rethink our understanding of the giant planet. What surprised you the most about these terrifying discoveries? Let us know in the comments below. If you enjoyed diving into Jupiter's darkest secrets like this video, share it with fellow space enthusiasts, and don't forget to subscribe to Sci and Y for more amazing space exploration stories. Until next time, keep looking up.